Probability of an event. Probability is the likelihood or chance for a particular event to occur. Event is a subset of a sample space. Events can stand alone or can be a combination of two or more events. And events can be represented by Venn diagrams. Let's look at some important events and their Venn diagrams. The first event is union event. A union B consists of all elements that are in A or in B or in both A and B. Union event is denoted by the symbol U. And union event is associated with the word OR. The second event is intersection event. A intersects B consists of all elements that are both in A and B. Intersection event is denoted by the symbol N. An intersection event is associated with the word N. The next event is complement of an event. The complement of an event consists of all elements that are not in that event. Complement event is denoted by the symbol prime. The last event is mutually exclusive event. Mutually exclusive event happens when the events in a sample space do not intersect with each other. The events are said to be disjoint. Probability of an event is given by number of elements in the event divided by number of elements in the sample space. Let's look at an example. A die is rolled once. Find the probability of getting a number less than 4 and the probability of getting an even number and a number greater than 2. To find probability of an event, first list out the elements in the sample space and then determine number of elements in the sample space. If we roll a die, we will get this sample space. We can see that there are 6 elements in this sample space. Thus, number of elements in the sample space is 6. Next, define the event of the probability that we want to find. List out the elements in the event and then determine number of elements in the event. The first probability that we want to find is the probability of getting a number less than 4. So define an event A to be the event of getting a number less than 4. From the sample space, the set of event A would be 1, 2, and 3. We can see that there are 3 elements in the set of A. Thus, number of elements in A is 3. The second probability that we want to find is the probability of getting an even number and a number greater than 2. There are 2 events here. The first one is getting an even number and the second one is getting a number greater than 2. So define an event B to be the event of getting an even number and an event C to be the event of getting a number greater than 2. From the sample space, the set of event B would be 2, 4, and 6 and the set of event C would be 3, 4, 5, and 6. We can see that there are 3 elements in the set of B, thus number of elements in B is 3. And there are 4 elements in the set of C, thus number of elements in C is 4. Note that the word N represents intersection event. Thus, the event of getting an even number and a number greater than 2 is the event of B intersects C. From the set of B and C, the set of B intersects C would be 4 and 6. We can see that there are two elements in the set of B intersect C, thus number of elements in B intersect C is 2. After that, calculate probability of the event by using formula. To calculate probability of A, take number of elements in A, which is 3, and divide it by number of elements in the sample space, which is 6. To calculate probability of B intersect C, take number of elements in B intersect C, which is 2, and divide it by number of elements in the sample space, which is 6. Let's look at another example. 90 people applied for a job at a hotel. Some of them are college graduates, which is denoted by G, and some are not college graduates, which is denoted by G prime. Some of them have working experience, which is denoted by T, and some do not have working experience, which is denoted by T prime. A person is selected at random. A. Find the probability that the person is a college graduate, that is the probability of G. B. Find the probability that the person has working experience, that is the probability of T. And C. Find the probability that the person is not a college graduate and has working experience, that is the probability of G prime intersects T. When we are given with number of people that have been divided based on two categories like this, the first thing that we need to do is find total of each row and each column of the table. The total value of the first row here represents number of elements in T, while the total value of the second row here represents number of elements in T prime. The total value of the first column here represents number of elements in G, while the total value of the second column here represents number of elements in G prime. Take note that the value in this box represents number of elements in G intersects T, which is number of people who are college graduates and have working experience. The value in this box represents number of elements in G prime intersects T, which is number of people who are not college graduates and have working experience. The value in this box represents number of elements in G intersects T prime, which is number of people who are college graduates and do not have working experience. Finally, the value in this box represents number of elements in G prime intersects T prime, which is number of people who are not college graduates and do not have working experience. Also, take note that the grand total of the table represents number of elements in the sample space. So now, from all this information, to find probability of G, take number of elements in G and divide it by number of elements in the sample space. To find probability of T, take number of elements in T and divide it by number of elements in the sample space. To find probability of G prime intersects T, take number of elements in G prime intersects T and divide it by number of elements in the sample space.